7.4, solve a log equation, and 7.5, property logs. So let's go through this worksheet. So you want me to solve this log equation. So the general key is, the way you solve logs is whatever the base equals, you want to take that base to both sides. So it's a little funky. So what happens is that these cancel out and you get a equals the base to the power of x. It's like another way of rewriting logs, but this would be more helpful to take the base of both sides, and you'll see why more when we get into it. So the first one here, you're like, okay, how do I solve this? Well, you just want to get the base to both sides. These cancel, and you get x equals 3 squared, so 9. X equals 9. The next one, well, no, okay, so this one you're not going to solve. It's just saying log base 2 8 equals x. Well, I can just figure out what that is. 2 to what power equals 8? The way you do logs, right? So 3. Done. Now this one, right, so I can take the x to both sides. These cancel and I get 81 equals x to the 4th. Well, now it's like a normal math problem. How do you get rid of x to the 4th? Do the 4th root of both sides. X equals 4 to 81 is 3. This next one here, right? So I gotta solve for this. The easiest way to do is take the base of both sides. So 81 to this, 81 to this. That's the way you get. That's the way you solve logs. So you get that. And now I gotta solve this. Now remember the trick to doing this. You always want to do the root first. This is a root, and this is a power. You always want to do the root first. So we're going to do the 4th root of 81, which we just talked about. That's 3. And now I have 3 squared, which is 27. So that's my answer. So you want to do the root first in that case. The next one, same idea, to solve it. To take the 6 of both sides. These cancel. 1 over 36 equals 6 to the x. Now on these, I got to make the bases match, if I could. 1 over 36 is the same thing as 6 squared. They still don't match because one's a fraction, right? That's a fraction. So I gotta flip it. So 6 to the negative 2 equals 6 to the x. X equals negative 2. Next one. Same idea, the base of both sides. These cancel. 32 equals x to the 5/5. 5/2. Now how do we solve this? We want to do reciprocal power. So same thing we did like here. Up here. There we go. Right, you did the 4th root of both sides. But that's the same thing as saying just doing the 1/4 to both sides. So you want to do reciprocal power. So we're going to take the 2/5 of both sides. And just like before, you always, when you have a fraction like this, you want to do the root first to make it smaller, which is easier. Now it doesn't matter, you can do the top part first, but I don't want to square 32 and then take the 5th root of that. It's much easier to take the 5th root of 32 and then square it. So the 5th root of 32 squared, 5th root of 32 is 2, 2 squared is 4. Log x of 27 equals 3/2. So same idea here. Rewrite it, take the x to both sides. 27 equals x to 3/2. And just like before, we want to take the reciprocal both sides. Do the root first, so cube root of 27. And we're going to square that. Cube 27 is 3. 3 squared is 9. The next one. So this is why I don't like to rewrite all the time, because you can't rewrite this. The way you get rid of these is you go log equals log, you take the base of both sides. Now what happens when you do that? They just cancel out, and you just get x squared minus 4x equals 3x minus 10. And now we have a quadratic. By the way, this is the same question. We're going to skip that one. It's the exact same question. Now we have a quadratic. When you guys remember how to solve a quadratic, set equal to 0, and then either factor or use quadratic formula. Or if you want to keep the square. But let's set equal to 0 first. Plus 10, plus 10. So I moved everything over, right? I try to make this side 0 because it has the x squared. I like to keep my x squared is positive, so move it over, subtract, subtract. So I get this, and again, you want to, in this case, factoring, so use this one. You need two things to multiply to get 10, positive 10, but add to get negative 7. That means they both have to be the same sign, so they're both negative. And that would be x minus 2, x minus 5. split and solve, and you'd get 2 and 5. Like that. Now with logs, you gotta watch out. So when you plug a log in, you can't have it be negative. So it hasn't been such a worry in all these, but now it is, because now we have like multiple answers. So when you substitute, you want to check your work. When you substitute it back in, you should not get a negative. One of these doesn't work. If I plug a 5 in, I get 15 minus 10, which is 5, that's fine. 25 minus 20, totally fine. If I plug 2 in though, I get 6 minus 10, which is negative 4. And you cannot have a negative. Logs don't do negatives. Remember the graph of a log? It looks like this, right? Negative has no value. So answer here was actually only 5. 2 didn't work. Let's go down to this one. Same idea. Take the 6 of both sides. X squared minus 6x equals negative 8. And now set equal to 0. Move the 8 over. Oops. Factor it. I need two things to multiply, get negative 8, but I had to get negative 6. So x minus 2, x minus 4. And actually, I just noticed this question, after all that talk I did, this question has a negative from the very start. That's not possible. So no solution. It would have been, we would have got 2 and 4, but this can't be negative. Logs can't do negative, so not possible, no solution. I'm not sure if it's an error by the book company or that's what they intended for it to happen. So now we're solving the basic log problems. Much like when we do square roots, the domain here is not all real numbers, so I actually do got to worry about the domain first. So I'm gonna do that. I always say that step 0. Do the domain. Now domain is much like square root. You look at the thing inside the log, and that thing must be greater than 0. So in this case, we got lucky. It's just an x, so that's my domain. X is greater than 0. At that, we can solve like normal. There's another reason we like to take the 6 of both sides, the base of both sides, because it keeps this guy straight. So x minus 6 to the negative 3, right? It keeps in the proper notation. If you just rewrote it, like, wait, do I change it or not? This one lets you know for sure. Just that to me less than still. The x is on this side, that's on that side. You could leave it like this, or you could rewrite it if you want to try and be fancy. 6 cubed is 216, but the negative makes it flip. 1 over 216. And then you could combine these two if you want. That's fine. Or you could say that's less than 216, which is greater than 0. So it's on the sides. The next one, same idea. Step 0, do the domain. Here it's going to be x, so how lucky? X is greater than 0. So easy. Then we just solve it, take the 5 to both sides. X is greater than 5 squared, or x is greater than 25. So in this one, notice how these ones are going opposite ways. It was less than this and greater than that. This one, it's a greater than sign. Well, so if you're greater than 25, you're already greater than 0. Like if you do a number line, they're both going in the same direction. So my answer is just the bigger one, or the one where they overlap, which is at 25. So this is just my answer. Compared to this one, if I did number line here, I'll be going that way, and then 1 over 216, I'll put it, let's say it's right here. That'll be going this way, so it's the overlap is in between. So that's the difference between these two. If you generally have a greater than sign, that's just your answer. You'll work with it generally. So the next one, again, I got to worry about the domain. So x is greater than 0. That's my domain. Then we got to solve it. Take the 7 to both sides, cancel out. X is less than 7 to the negative 1, or x is less than 1 over 7. And these I could, there we go, that's my answer. Or I can combine it. There we go. The next one's more annoying. It is a greater than sign, so I have to worry less about the domain. But I do got to worry about the domain because there's 2 of them here. So how do I do that? I do both of them. I got x plus 2 is greater than 0. So x has to be greater than negative 2. And I got the domain of this one. 6x minus 3 is greater than 0. So 6x has to be greater than 3. X has to be greater than 1/2. So already this is going to win. If you have to be greater than 1/2, because you have to be greater than both of these. Now let's solve it. Take the 7 of both sides to get rid of the base. These cancel out. X plus 2 is greater than or equal to 6x minus 3. Notice my domain here was always greater than. It doesn't matter what this sign is. Domain is for logs or just greater than. From here to solve it, let's see, minus x minus, I don't like having the x on that side. I'll subtract 6x. I don't like doing this though. So I get negative 5x is greater than or equal to negative 5, divided by negative 5. X is less than 1. So I got x is greater than negative 2, x is greater than 1/2, x is less than 1. If you want, you could plot all that. Where do they all overlap? It's actually only right here. Right, so again, this one was, that one actually doesn't really matter. It's all about these two. So greater than 1/2 and less than 1. So this and this is my answer. Next one, same idea. I gotta do domain first. 9x plus 4 is greater than 0. Greater than. X is greater than negative 4/9. That kind of sucked. 11x minus 12 is greater than 0. So x is greater than 12 over 11. Okay, and then we gotta solve it. Take the 9 on both sides because of the base. These cancel, you get 9x plus 4 is less than or equal to 11x minus 12. Oh, again, they're doing this to me. Let's subtract 11. I don't like doing that. I like to keep my x is positive. Minus 14. I get negative 2x is less than or equal to negative 16. Divided by negative 2. X has to be greater than or equal to 8. So I need all these together. And what's my answer? Well, this one's going to be my answer. Right? 8's going that way. All those other ones are smaller than that. It's where they overlap. And they're all going the same direction. So I'd like 12, 9, 11, so that'd be going that way also. Negative 4/9 would be going that way also. So my answer is only where they all overlap, which is just this guy. Next one's a normal log problem. It's kind of hard to see there on my clutter. But all we have to do here is take the 16 on both sides. These cancel out. I get x is equal to 16 to 3/4. Remember, all we do there is do the fourth root first. We do the root first always. Makes this easier. You can do either one, but it does make it easier. And then we can cube it, so it makes it 2 cubed, which is 8. So for this, I just want to know if each statement is true or false. So remember the adding rule. When you add logs, it's multiplication, so this is true. Over here, when you subtract log, this should be division, so it's actually false. This equals log 8x over log 8/3. Here, that's not true, right? This is much like this one. You separate them, so this is false also. This one is true. It's one of my favorite rules, right? If you have something in front, you can move it to be a power of the next guy. That's that guy. That's true. Dividing and subtraction, that's true. So true. I'm not sure I'll put a check mark for. And then, did you just break up logs like this? No. That's not it, right? This means multiplication. This would be 2z. So this is wrong. False. Okay, we're going to last thing we're going to solve. So this is going to do a little more work. So the most common problem here is people just cancel all the logs. You can't do it unless there's a log on each side. So actually step 1 here is condense. So you got to combine these two. So you can't just like cancel all the logs, you got to combine those two first. So plus means multiplication. So you get log 3 2x times 7 equals log 3 of 28. And then now I can solve it. Take the 3 to both sides. Right, let's say get rid of logs. These cancel out, these cancel out. I get 14x equals 28. Divide by 14. X equals 2. Same thing here. So there's actually lots of ways to do this. No, there isn't. There's not a good way besides doing this. So this one, you can't just take the 2 to both sides first. There's a 3 in your way. So it has to be just like perfectly only a log on either side. So 3 is my way. So what I can do with this is move it up here. Make it log 2x cubed equals log 2/8. And now I can get rid of the logs. Now there's only a log on each side. I can take the base of both sides. These cancel out. And I get x cubed equals 8. Cubed root both sides. And x equals 2. There we go. It's the lesson.